So we need to find the electric field at the origin due to these three charges. So the electric field due to charge 1, positive charge, is going to point away from the positive charge, and that'll be in the minus y direction. The electric field due to charge Q2 is going to point in the direction of charge Q2, because that charge is negative, and electric field lines point toward negative charges. And the electric field due to charge Q3 is going to point down toward charge Q3. Alright, so we just need to add these vectors up. So first I'm going to find the magnitude of each vector, the magnitude of E1, KQ1 over R1 squared. So gives us 33.5 newtons per coulomb in the minus y direction. Magnitude of the electric field due to charge 2 Now notice that I left the minus sign off of the 4.4 because we're just calculating the magnitude of the electric field. It actually points in the plus x direction. So there's no sense in using the minus sign there. And then we can calculate the electric field due to charge 3 very quickly. Again, I'm leaving off the negative sign. And I get 89.2 in the minus y direction. So the magnitude, I don't really have to break these up into components because they're already in components, right? None of these is with respect to an axis or something like that, 30 degrees above plus x or anything. So the total x electric field is just equal to E2, which is 54.8. Okay, and it's positive. And the total y electric field is the combined E1 and E3, which is minus 123. Okay, so to calculate the total electric field, I draw myself a little Cartesian coordinate system, and I go 54.8 in the positive x direction, and I go 123 in the negative y direction. Notice that this is positive now, but the fact that it's in the minus y direction, I've drawn that in, so there's your negative information. Okay, and I'm trying to find the hypotenuse here, E total. Okay, so the magnitude of E total is going to be found with the Pythagorean theorem. So that's going to be 134 newtons per coulomb. And then this direction theta, well, theta is the inverse tangent of opposite over adjacent. Again, I'm not using a negative sign here, right? I'm just trying to find theta, and theta's for a triangle. I don't use a negative sign there, because if you use a negative sign, then your calculator is going to think your theta is up here somewhere. So theta is going to be 66 degrees below plus x. Now here's my information about it being negative, right? I drew that in. I always, whenever I'm doing any trig functions, I always just use positive numbers just to keep things simple. Now, I guess I need to round this off to 130. I need to round it off to two significant figures since that's all that was giving me the problem. And there's my answer.